We're going to graph rational functions. Now, I have a picture of Mark Twain here for a rewrite because we need things in what we call factored form and what? Expanded form, right? Well, here's what's really nice. This one is factored and it's also what? Expanded. So we don't have to do anything. So on number one, you know, make sure to rewrite that one in your factored or expanded column. Make sure you got your papers. Yeah, that's number one, the first column answer, all right? Because factored and expanded were exactly the same, okay? How do you find the Y-intercept? Now you need to look at the expanded one, and is it the left or the right, top or the bottom? To find the Y-intercept. You remember from yesterday? Which side is it to find the Y-intercept? It is the right. It is the right. So I'm going to box in the right side, right here. And base simply, what is negative 4 divided by 2? Negative 2. So the Y-intercept is the point 0, negative 2. So I just found the Y-intercept. It's 0, negative 2. Okay? Whoops, kind of got ahead of myself there. But what is the horizontal asymptote? We box in and the box already appeared. This time we're boxing in which side? The left side. Ooh, go ahead, the button's too fast here. The left side, and this is 1 over 1, so y equals 1. Okay, y equals 1. So that was the expanded version. Now on the factored part, these will be the top, all the tops and the bottoms are numerators and denominators. First off, for there to be a whole, look at the factor side, and is there any factors that are exactly the same? And the answer here is what? None. And it already shows up here. I think I forgot to make that one pop in, but the answer is none. There's no whole, okay? You will have some more holes today when we do the work, just not on this one. The X-intercept. Which one do we box in for the X-intercept? The top. Box in the top for the X-intercept. Because this is when your answer equals 0. And the only way you can get an answer of 0 is if the numerator is 0. Because you can't have 0 in the denominator. So this has to equal 0. Well, what would make this equal 0? Inside liar would be a what? Positive what? 4. So the X-intercept would be the point what? 4, 0. So on your paper, that's the roots. You can change the word root to X-intercept if you want. Okay? X-intercept. All right? The vertical asymptote, which one do we box in? What's the one we haven't boxed in yet? Yeah, we've done left, right, top, so it's the bottom. And basically, what will make this one equal 0? Negative 2. Okay? So the asymptote will occur at x equals negative 2. Right? And then what I really like about the next one is the domain. Because the domain will be basically what? It's the same answer as your asymptote, except it cannot equal it. And the reason is, the asymptote actually occurs when it equals 2, and domain means every single number in the world works except for what? Negative 2, because it was a asymptote. Now, if there had been a whole, asymptotes and wholes are not part of the domain, but everything else works. Okay? Now, y'all, this is what we did yesterday, right? We kind of boxed in and found these things, okay? That's why you have the paper there. That's your chart. We're going to do that today, but here's what we're going to add to it. We're going to graph it. Now, I'm going to show you how I graph these. And here's where I would start. I would start with the vertical asymptote. Where was the vertical asymptote at? Negative 2, correct? So, if it was at negative 2, I'm going to draw a dotted line where x equals negative 2, like this here. Now, I made mine in a different color. If you have some colored pencils and stuff, that's really good to help with that. Colored pencils will help out a lot, okay? So, negative 2. I'm next going to graph the horizontal asymptote, which was at 1. That's 1 over 1 right here. Y equals 1. And so the horizontal one will look like that at 1. I have this nice little horizontal asymptote here, and I make those kind of dotted lines or dashes. Really, dashes would be the more the correct word than dotted lines, okay? But I'm going to do the asymptote there. Make it nice and easy to see. And now what I need to do is this here. I need to find some points, because here's what I don't know. I know I'm going to have curvy L's because my lines can never what? Touch these red ones here, these asymptotes. But my problem is I don't know whether my curvy L's are up here, down here, where they're at. So we got some points we can check out, right? First off, they give us some points. We already found which point, the what? So let's find it. The y-intercept was 0, -2. Let's put a dot at 0, -2. So you know what that tells me? I know I'm going to have one curve EL where? Somewhere, what? Over here on the bottom side, right? I'm also going to do this here. Where's the x-intercept? It was at what? 4, 0, which is right there. Okay? So I know one curve EL is down here. So to be a function, it can't have an answer up here. So that means this other side is either going to be what? Up here or down here. How can I figure out which one it will be? Anybody have an idea? Oh, there were no holes. There were no holes on this one. Oh, I forgot about that. So how can I figure out whether it's what? Well, first off, let's pick a number. Let's pick a number that is left of -2. Well, what's probably the easiest number to check left of -2? What's the first one higher than -2? -3. So let's plug -3 into the problem. So I'm going to come up here and I'm going to plug -3 into my problem. Well, -3 minus 4 is -7. -3 plus 2 is -1. And what's -7 divided by -1? +7. So I have a point at what? -3, 7. So that means my curve EL will be where? Up what? Here. Now y'all, I don't really care if you make your curve EL, like, you don't have to make it perfect, but you got to make one what? Up here, and we got to make one where? Down where?
There.
Down there. So when I do that, there's that one, and then there's this one here. And my little dot moved over on me a little bit right there, it looks like. But that's what my curve EL should look like, something like that. Okay? It should look like that. All right? Now here's what's really nice. Okay? Well, what's really nice, one other thing is, I did this here, that's by hand. Let's look at it, what it might look like on a calculator. Okay, y'all? Let's go to my y equals, or turn it on. Y equals, let's clear that one out of there. Now, something I just kind of found out about, and y'all probably know about, is I'm going to type this in. Now, y'all, I'm going to type it in the old way if you don't have a super nice calculator, where this has to be in parentheses. So I'm going to type, all the top has to be in parentheses, for all the numerator, if I use the correct terms, x minus 4, close the parentheses, divided by, and all the denominators got to be in parentheses, or on the bottom, x plus 2, and close the parentheses. And I'm going to do this here, I'm going to hit graph. And notice, does my graph look like that one? Yeah, you can see it's kind of a little bit above right there, right? Goes right there, right there. Notice, this doesn't show the asymptotes, does it? But you can kind of tell where they were. But here's what's really nice, too. If I go to second table, you see an error at what? -2, because where was the asymptote? -2, okay? So, and if you look through there, you won't see any answers of 1. Throughout the whole thing, you'll see no answers of 1. And as we go, as I arrow up with the negative numbers, you can see it's getting closer and closer to 1, but it doesn't actually what? It will never actually what? Hit it. So just kind of, you see they get real close there. And the same thing's true this other way. It's going to get real, real close to 1, but never what? But never hit it. And the calculators are real helpful to make sure you did your work correctly, and also what it looks like.